Welcome back to the deep dive. You know the drill. You send us the topics and the sources, and we dive deep to pull out the core insights for you. It's your shortcut to getting up to speed.
Yeah, think of it as us doing the heavy reading so you don't have to.
Exactly. And today, we're tackling something really interesting, building AI apps that can, actually use tools, like interact with things.
Right, and the sources you sent point towards this new standard, the Model Context Protocol,
Yeah.
MCP, and how it works with tools like Hugging Face and Gradio.
That's the one. So our mission today, break down what MCP is, how it helps AI agents use external services, and try to make it click without getting lost in the weeds.
Definitely aiming for that aha moment. And we're working primarily from the Hugging Face MCP course docs. They cover quite a lot, from building the apps end to end, the servers, the clients.
Even those tiny agents they mentioned. Sounds intriguing.
It is. So the promise is, by the end of this, you'll have a good handle on MCP and how Hugging Face tools make building these smarter apps, well, more accessible.
Okay, sounds like a plan. Let's kick it off. Fundamentally, what is MCP?
So MCP, at its heart, it's a standardization protocol. Think of it like a universal translator.
A translator for AI.
Kind of, yeah. It creates a common language for AI models or agents to talk to and use all sorts of different external tools and services.
Oh, okay. So instead of custom instructions for every single tool.
Exactly. MCP gives them a standard way to figure out what a tool does and how to use it.
Okay, like a universal adapter plug for software tools. What's the big win there?
The main benefit, really, is simplifying what's called agentic AI development, building AIs that can act. It provides a standard way for these agents to discover tools, understand them, and then, actually use them. It takes away a lot of the usual complexity.
Right, smoothing out the connections between the AI's brain and the tools it can use. That makes sense. So how does Gradio fit into this?
Gradio is really flexible here. It's kind of like a Swiss Army knife for MCP. Well, it can be both an MCP server, the thing offering the tools, and an MCP client, the thing using the tools.
Oh, interesting. Both sides of the coin. So tell me about Gradio as a server first. How does that work?
It's surprisingly straightforward. If you've got a Python function you want an AI to be able to use, you can wrap it in a Gradio interface. The thing that builds web UIs.
Yeah, I've used those.
Right? When you launch that interface, you just add one little parameter.
MCP server.
True. That's it. Seriously. What happens then?
Well, behind the scenes, Gradio does the heavy lifting. It takes your Python function and sort of automatically translates it into an MCP tool.
How does it know how to do that?
It looks at your function's inputs and outputs, figures out the structure, and maps that to the standard MCP format, the schema. It also handles setting up the communication protocol.
The techie stuff.
Yeah, the JSON RPC over HTTP plus SSE server sent events. Basically a way for the server and client to talk efficiently. And the cool part is, it does all this while still giving you the normal web UI for humans. So I write my Python function once, set that flag, and boom, I get a web page for people and an MCP endpoint for AI.
Exactly. 2 for 1, super efficient.
Can you walk me through an example?
Sure. The docs use a sentiment analysis tool. You build it with a library like TextBlob in Python. The function takes text, returns sentiment positive, negative, neutral.
Okay.
You wrap that function in gr.interface, set MCP server true, run it, and instantly you have a web page to test sentiment and an MCP tool endpoint that an AI agent could call to do the same thing.
Neat. And where would these things live, typically, if I run it locally?
Default setup. The web UI pops up at http.localhost.7860, and the MCP server endpoint, the one the AIs talk to, that'll be at http.localhost.7860 Gradio APNCP0.
Good to know. How would I check what tools my server is actually, advertising?
Gradio gives you a schema endpoint for that. Just go to Gradio PIMC schema on your server's address. So http.localhost.7860 Gradio PIMC schema.
And that shows?
It shows the blueprint, the names of the tools, descriptions, exactly what inputs they need, what outputs they give. It's all laid out. Sometimes there's even a link in the footer of the Gradio app itself.
Very useful for debugging, I bet. You mentioned type hints and doc strings in Python earlier. Are they important here?
Oh, absolutely critical. They're not just good practice in this case. Gradio uses the type hints to figure out the data types for the tool's inputs and outputs.
So it knows if it expects text or a number or whatever.
Exactly. And the doc string, especially the argument descriptions, Gradio uses that to automatically write the description for the tool in the MCP schema.
So good comments and types directly translate into a usable tool description for the AI.
Precisely. It's how the AI understands how to use your function.
Got it. Okay, so Gradio as a server Makes sense. What about the other side? Gradio as a client, using tools from other servers.
Yeah, it can do that too. You can build a Gradio app that connects to external MCP servers and uses their tools within its own interface.
So my Gradio app could pull in capabilities from other places.
Mm-hmm. Imagine building a research assistant app in Gradio. It might have its own text summarization tool, but maybe it reaches out to your sentiment analysis server we just talked about, running somewhere else entirely.
Okay, that sounds powerful. How do you actually set up that connection?
The docs show an example using some specific Python libraries, mainly Small-Agents MCP and MCP client, alongside Gradio MCP. You basically write code in your Gradio client app to create an MCP client object.
And point it at the server.
Yep, you give it the URL of the MCP server, like that Gradio Pinks endpoint we discussed. The client then connects, asks the server, what tools do you have? And gets back that schema list.
And then, my Gradio app just knows how to use them.
Pretty much. The example uses small agents to build the actual AI agent part. You give this agent a task, like analyze the sentiment of this review. The agent looks at the list of available tools, sees the sentiment analysis tool from the remote server, and figures out, okay, I should use that.
So the Gradio UI becomes the front end for this agent that's coordinating different tools.
You got it. The agent is like the conductor, and the tools are the instruments, some local, some remote.
That's a really cool way to build complex apps. Now, you mentioned clients don't have to be Gradio, right? Other languages.
That's right. MCP itself is language agnostic. So while Gradio is great for Python, you could build a client in JavaScript, for example. That's where huggingface.js comes in. It has libraries to talk MCP from JavaScript.
So you could build an agent right into a web page.
Exactly. Talking to potentially Python-based Gradio servers or any other MCP compliant server.
Okay, but how do all these different clients, Python, JavaScript, whatever, know where to find the servers? Is there like a directory?
Not quite a directory, but configuration files are key. Usually simple JSON files. An MCP host might use mcp.json.
What's in that?
It basically lists the servers the host knows about. For each one, it'll have a name, the transport type like S for the Gradio servers, or maybe even Studio if it's a local program acting as a tool provider.
Yeah, Studio. Like standard input-output.
Yeah, so you could have a command line tool act like an MCP server locally. And crucially, the config file has the URL or path to connect to it.
Can you show me what that might look like? A simple one.
Sure, something like this. Servers. Name, remote sentiment server, transport. Type se url https.some-server.com for handing mtpsc. Pretty straightforward.
Okay, just a list of servers and how to reach them, and UI clients might use a similar file.
Yeah, Gradio clients sometimes use a config.json that looks a bit different, maybe like MCP servers, MCPS on, http.localhost.7860, Gradio ping CPS, but the idea is the same. Tell a client where the servers are.
Got it. An address book for tools. Now, the really interesting part, how does the AI actually decide which tool to use and when? You mentioned LLM tool calling.
Right. This is where the magic really happens. Modern large language models, the really powerful ones, have this ability baked in now. It's called function calling or tool use.
What does that mean exactly?
It means the LLM itself can look at a user's request, look at the list of available tools described by that MCP schema we talked about, and decide, hey, to answer this properly, I should use the sentiment analysis tool with this specific text.
Whoa. So the AI isn't just generating text, it's generating instructions to use a tool.
Precisely. It understands the tool's purpose and parameters from the schema Gradio generated. It knows what the tool needs.
And Gradio generating that schema automatically from Python types and docstrings is key then.
Absolutely key. It provides the structured information the LLM needs to make that decision and formulate the correct call. It needs that precise JSON schema, the instruction manual.
Okay, so walk me through the flow. I ask the AI something.
Right. You send your request plus the list of available MCP tools to the LLM, maybe using something like Hugging Face's inference client.
And the LLM might respond with.
Instead of just text, it might respond with a special marker indicating a tool call. This call contains the name of the tool it wants to use, like sentiment analysis, and the arguments it figured out should be sent, like text, this movie was great.
Okay, so the LLM says, use this tool with this input. What does my client code do then?
Your client code sees that tool call. It uses MCP to connect to the correct server using the info from mcp.json or similar, sends the tool name and arguments, and executes the actual function on the server.
And the server runs the function, gets a result.
Sends the result back to your client via MCP. Your client then takes that result and feeds it back into the LLM.
Ah, So you tell the LM, okay, I ran the tool like you asked, and here's what it said.
Exactly. And the LLM then uses that tool's output to formulate its final answer to you. It's a loop. LLM decides, client executes tool, result, fed back to LLM. LLM continues.
That's much more dynamic than just text generation. It's like the AI can pause, run a calculation, or look something up using a tool, and then resume its thinking.
That's a great way to put it. It lets the AI interact with external capabilities.
This brings us to those tiny agents mentioned in the sources. A 50-line demo. That sounds like a great way to see this in practice.
It really is. Tiny Agents is this minimalist MCP client in TypeScript, JavaScript. It's designed to show the core concepts very clearly.
And in just 50 lines, it can connect to MCP servers and use tools.
Yep. It connects, lists the available tools, uses an LLM via the inference client again to decide which tool to call, and then executes it. It's surprisingly powerful for its size.
What tools does it connect to by default?
Out of the box, it's set up to potentially connect to two interesting ones, a local file system tool.
Whoa, access files.
Yeah, potentially, with the right permissions, of course. And another one that controls a web browser using Playwright.
So it could browse the web or interact with local files. That's pretty advanced for 50 lines. How do we add our Gradio sentiment server to it?
The demo shows how. You add an entry to its configuration. It uses a helper tool called MCP Remote.
MCP remote. What's that?
It's like a bridge. Tiny Agents expects to talk to tools as if they were local processes sometimes, but our Gradio server speaks HTTP plus SSE. MCP Remote translates between them.
Okay, so you tell Tiny Agents to run MCP remote and point that at your Gradio server's URL.
Exactly. You add a config line like command npx args and MCP remote httpo.localhost.7860 Gradio pimcpx.
And then the sentiment tool just appears in the list of tools the Tiny Agent can use.
Yep. The McClient class inside Tiny Agents handles discovering all tools from all connected servers, file system, browser, your Gradio server. It passes that full list of available tools to the LLM.
And when the LLM decides to call the sentiment tool,
The client.callTool method knows how to route the request through MCP Remote to your Gradio server.
so the core logic is connect, list tools, ask LLM, call tool if needed, repeat.
That's the essence of it. The agent class in Tiny Agents just adds a system prompt for the LLM in that basic loop. It even includes a couple of meta tools like task complete for the LLM to signal when it's done, or ask question to ask the user for more info.
Seeing it boiled down like that makes it much clearer. Okay, last piece. Deployment. Making these things accessible via Hugging Face spaces. Why is that useful?
Well, running things locally is great for development, but Spaces lets you share your MCP servers and clients easily. They become web services anyone can potentially connect to.
Makes sense. So how would I deploy that Gradio sentiment analysis MCP server to Spaces?
Pretty easy, actually. Create a new space, choose the Gradio SDK. You'll need a requirements.txt file listing your dependencies, grade MCP, and text blob in this case.
Okay.
Then you just push your Python code, server.py, and that requirements.txt file to the space repository.
Hugging Face handles the rest.
Yep, it builds the environment, runs your Gradio app, and gives you a public URL. Your MCP server endpoint would then be something like https.your-spacename.hf.space-gradio-apimcpc.
Nice. And deploying a Gradio client app that uses that server.
Very similar process. New space, Gradio SDK, requirements.txt would list the client libraries, creating MCP, maybe small agents as MCP. Push your client code.
But the key difference is
You need to update the client's configuration, that config.json, or wherever you store the server URL, to point to the deployed server's public spaces URL, not localhost.
right, so the client knows where to find the server out on the web. That really does open up possibilities for creating an ecosystem of interconnected tools hosted by different people on Spaces.
It really does. It encourages modularity.
Yeah.
Build a tool, deploy it, let other agents use it.
Okay, great stuff. As we wrap up, let's quickly recap the main takeaways from this deep dive.
Sure. Number one, MCP is this crucial standard making it easier for AI agents to use diverse tools. Number two, Gradio is super versatile here. It can be the tool provider, server, or the tool user, client, often with just a few lines of code.
And number three, the magic enabling the AI to decide to use these tools is that built-in LLM tool calling or function calling capability.
Exactly. Those three pieces fit together really nicely.
It really paints a picture of future AI agents being able to seamlessly pull in functionality from all over, automating tasks, doing analysis.
Yeah.
It's quite exciting.
Definitely. And if you want to learn more, the Hugging Face MCP course docs are the place to start. Check out the Gradio examples too, and that Tiny Agents project is really insightful.
And the official MCP spec itself for the really deep dive.
Those are really curious, yes.
So, a final thought for you, our listener, to chew on. Standards like MCP are clearly vital for building these more capable, interactive AI systems. Makes you think, doesn't it?
Yeah.
What other areas of AI could really use this kind of standardization to unlock the next level of progress? Something to ponder. Thanks for joining us.